Okay, last two slides, let's go. So today we are finally going to look at what Valgrind is, and honestly this is super weird because like you have dealt with Valgrind for so long in this course and suddenly I'm like, hey, this is you actually how you actually look at Valgrind. And yeah, the syllabus is kind of messy and well, you already learned it, so this video is just a validation of what you learned so far. So what is Valgrind? For our purposes here, it's a front end for managing a collection of dynamic code analysis tools, including two complementary memory analysis tools, MemCheck and SGCheck. Okay, so the MemCheck is a memory error detector aimed at errors in handling dynamic memory errors. So whenever you get something like memory corruption or like not enough memory allocated or out of bounds, this is what it checks. And SG check is an experimental memory error detector aimed aimed overruns of array of stack and global areas. So whenever you are going outside like out of bound errors, this is the one it checks. We'll examine the basic use of the Valgrind. Honestly, you have already seen this by now, but like this is just a formal explanation of the whole thing. So yeah, this is a very simple code we are going to take a look at. This is pretty simple. This is a header or like declaration of the function f. This is where we're calling it, and inside the declaration we are going to do this int x, int star x equals malloc 10 into size of int. Okay, so we are creating a array, int array of size of 10. So it's going to have 0 1 2 and till 9, and then we are going to try x10 equal to 0. So we are going to try put something over here that doesn't exist. So from your experience, you already know that the Valgrind is going to be able to check that. So let's see what it does. So when we run it, this is what it's going to look like. It's going to directly point over here, like literally at this line saying that there is a invalid write of size 4. Okay, so this kind of gives us a intuition of what went wrong. Let's take a look. So the 4 over here means byte. Okay, so we know that a invalid write of size 4 byte, so some sort of integer was being written where it shouldn't be able to. So over here we see that x shouldn't be able to access its 10th index, and it's trying to write something in that memory integer, so it's 4 byte. So that's how you actually understand how to like interpret the output of Valgrind. Okay, so it also shows that 40 bytes in one blocks are definitely lost in the loss record 1 of 1. So it says that some sort of block is being lost. Okay, so over here we see that we never freed it, right? So after it goes outside the function, this memory is being lost, and that's why it's telling you that whatever was being called over here, it wasn't freed. So whenever you get a error message in Valgrind like this, it basically means that you didn't free something. Okay, and another idea you can get from here is it says 40 bytes. So how do we get 40 bytes? It's 4 into 10 bytes, right? So it's going to be an integer array that has a size of 10, which is basically this. So these are some of the options you have for Valgrind. There's like leak check, show leak kinds, track origins, verbose, like be more expressive, log file, like where you want to put it. So whenever you ran your Valgrind in the command line, these are the ones you used. You already have pretty good idea about this. So yeah, let's keep moving. So one of the types of problem you face, like you see in Valgrind is like invalid write size of 1. It says size of 1, so 1 byte. So it's either a character or a short. Okay. um, it also says invalid read size of 1 byte. So again, it's the same thing, but over here it tried to write something, over here it tried to read something. So let's take a look at what may have went wrong. So over here we see that we have a character array. We are creating it with the size of 5, and then we are trying to do a sprintf. Okay, you know that sprintf is going to read from this label. Sorry, this is where it's going to print it. So this is the string where whatever is trying to be printed over here is going to be there. It says 5s. Okay, so 5 is 0 to d and 7s. So we are trying to print a v, then we are trying to print the index, and then we are trying to print the word. So it should be done normally. So let's see what happens. Like, let's see where it went wrong, because this Valgrind issue is pointing us to line 225, which is over here, and this one is pointing us to line 222. So it's telling us that something went wrong over here. Okay, so we know where to look at. Now let's try to understand what may have went wrong. A character array of dimension 5 is allocated and zeroed because we are doing a calloc, right? It is used in a normal way. This should not hold more than 4 characters because it needs a position of 0. Okay, so what happens is whenever we are trying to print this over here in label, it has a v, then index, which could be like 1, 2, 3, or whatever. Let's assume 1. So it's going to be v, then it says 0, 2. So 0 and then 1. Okay, then it's going to be a colon. It already filled up the 4 positions. Then we are printing a string called word. So this is way beyond 4. So that's why there's going to be some sort of invalid write over here. Okay, so more than 4 characters are written, and that's why it happened. And since strcopy depends on the terminator, it reads past the end of the array level. Okay, so another thing, if you try it by yourself, you will see that this is not true anymore. That's because of the optimization of the compiler itself. So never trust on it. Always make sure that you have enough space for your string or whatever. Okay. So another type of error you will see is that uninitialized fellows. So it could be something like conditional jump or move depends on uninitialized values. Okay, so usually you will face this when you are trying to use a value that isn't initialized, but sometimes it also may happen if you are trying a object file that was compiled in one OS, but you are trying it in another. For example, if I give you a object file I compiled in CentOS, and if you try to use it in Ubuntu, you are going to face this error. Like I actually suffered through it, so trust me on this. But usually it happens when it has some sort of like uninitialized value. So it says that it's in main and line number 155. So it says over here it happened. We have current line. We are trying to use JT mnemonic and name. Okay. Then it says that it happened in line 40. So from line 155, we are not actually sure from this like how it could have happened. So it says that one relevant fact is that sprintf depends on terminators to determine the end of the two strings it prints. Makes sense, right? So let's take a closer look at the code and try to figure out why it happened. So over here we have two variables, JT mnemonic and name. We are trying to write over here, so we know that um, it's not the problem we are looking at, because it says that it's going to be a problem with uninitialized values. So we have two other values, JT mnemonic and name. So let's see where they were made, like any sort of changes were made on them. So over here we have a type j type JT, and we are doing some sort of parsing with current line. Okay, so we are actually initializing it, so we know that this is not actually the problem. So on sorry, my bad. So on line 149, sprintf will not write a terminator to names like this. Why? That is the reason. So remember, I always tell you that you should at least initialize it with 0 or do calloc, or make sure that you run a for loop. This is why. Because if you, okay, and there is one problem over here, I'm going to mention it soon. So initially, like how C worked was, when you are using sprintf, um, whatever formatter you put over here, this whole thing is going to be copied over here. So it's like str copy, but you actually can use a formatter over here. Okay, so initially sprintf didn't copy any 0. So if you wrote this, it would just copy L, and then it would copy 0, and then like something 1 or something like that, and it wouldn't have any null terminator. So it has a uninitialized value, which is name, right? And that's why Valgrind shows that error. But in recent times, sprintf actually puts a 0 after the string, so you will not see this particular error. But like I don't know why Professor McQueen made it like this. I tried it myself and I couldn't recreate this problem. So maybe because of the optimization of current compiler, you won't be facing this, but you will face it if you try to work like if you try to use um, like instead of using strcopy or something like that, you write a for loop yourself and not put a 0 at the end. But in this case it won't be happening. Okay, it's just an example, it doesn't work. So there are other sorts of like memory leak. It actually gives you like, whenever you went through the Valgrind output, you always saw some sort of like output like this, right? It said like it is losing this many bytes in this many blocks and all of those. It kind of gives you an idea of what the problems are, but like the detailed problems are what you should be focusing on. Like it says that there's some sort of like calloc call that failed, or like that didn't work, and it gives you a line number. And remember, to get this line number, you have to make sure that you compile your file with minus ggdb3 or g. It basically creates a debug, your executable file is a debug version, because it has all the detailed information inside it. That's why you can actually see the line number. But whenever you want to ship your like software or product or whatever, in that case you shouldn't be adding ggdb3 or g, because in that case any hacker will have all sorts of information they need about your product, and they can just like hack it. Okay, so yeah, memory leak, it actually tells where it happened, and usually memory leak means you actually didn't free it. So whenever you are done with a dynamically allocated memory, you should make sure that you free it. Okay. So yeah, Valgrind helps you to write more cleaner code. If you don't write a cleaner code, it's called a spaghetti code, mom's spaghetti. So yeah, do not write that because I already gave you examples about what happens if you have memory leaks in your code. Like at one point you won't have enough memory to work with, and maybe your program will crash, and that might lead to very terrible situations like even um, nuclear explosion might happen just because of that. You have already probably watched Chernobyl, so you know that how bad that can get. So whenever you are working with memory, make sure that you are very responsible about it. And for more information, you can go here. Like it gives you the general functions that you can use for Valgrind, all of those. You have already experienced Valgrind enough in this course, and it's going to really help you in 2506. So yeah, I think it's a pretty short video. I hope you like the whole Valgrind thing makes more sense to you. So yeah, we have one more video left, and after that you are done. And I will probably make a summary video of like what you learned so far and what you should be focusing on in this course, or like what is your takeaway from this course. So yeah, see you next time.